Okay, welcome. We're in the last lab here. We're going to learn about fault injection and traffic shifting and circuit breaking, rate limiting. And there's two options here to populate our project with a different application, our lab, and that's inventory and catalog for a cool store. We want to pick the second one. My experience is that the first one fails about 2/3 of the time, and it says if it fails, use the second one. It's going to be faster just to do this right out of the chute. So let's start with that. Go ahead and control this. I'm going to stop this loop. And this is going to take about 5-6 minutes, so I'll just pause the video. Okay, that took care of our application deployment. We're up to speed here. Now we're going to do, a sidecar injection. So we brought back this application that we've worked with in other modules and put it into our system. If I go Red Hat here, OpenShift, and I can take a look at catalog, and here's a catalog application for the Cool Stuff store, and there's an inventory, and but this is right now not automated by Istio. We took an old deployment, brought it back. We're going to inject the sidecars into the system by using a little bit. I can confirm that the application is running. Actually, we just took a peek at it, so I probably don't really need to do this, but to follow the directions here. Yep, there's our catalog with both the database and the front end. Here's our inventory. And those pods are ready, one of one. Now, if we were to do a patch here of the inventory application, I think we'd see 2 of 2. Yeah, so by adding another container image into the pod, another container in the pod, we have to redeploy those pods. So here's inventory. Yep, the database is already up and going, and the old pod is terminating, and the new 2 of 2 is running, which is what we want to see. And then we need to do the same thing. We need to inject that sidecar, envoy sidecar, into the deployment for the catalog. There we are. Yeah, we had to have a restart. It took 2 tries for the inventory to come up and going because it had to wait for the database to be done. So once the database was finished, it did another deployment of a restart. That's pretty cool. Handles it automatically. And now we'll create a virtual service to send the incoming traffic to the catalog. Now they're going to have us actually specify the YAML. We're going to do a virtual service named catalog default and specify the ingress host here that's going to be supplying the traffic and the gateway. And here we see that the URIs that it'll match. So we're going to do this. We need to put this into catalog default YAML. is up in the catalog, rules, catalog default YAML. That's an empty file we can see up here. Center click will bring it in. Okay. And then we'll invoke that. We'll create that pathway here from that definition. And at this point, we should be able to go to the catalog service page. And there it is. We can see the catalog contains the price information, but we're also calling the microservice inventory to see the inventory results here. Okay. Now we're going to inject a sidecar. Oh, we're going to see how this looks in Kiali. Make sure I don't waste our time. We need to go to traffic animation, and we need to use inventory and catalog namespaces. Okay. Okay, inventory and catalog are specified. Let's go to traffic animation. All right, and we can see here's our catalog. Go to the catalog database, and we go to the inventory, inventory program, inventory database. So that's all working as we would expect and hope. Now we're going to try, this is sometimes difficult to simulate failures or latencies that exist in the real world, but the service mesh itself has the ability to do these kinds of failures, to be able to set timeouts, bounded retries, limits, health checks, fine-grained breakers. So let's play with that a little bit. We're going to actually put an inventory rules set up here. This will inject a 50% failure rate on the service. Inventory default. Actually, this is the default before we do that. Okay. Get rid of the direct route. And then we'll have a new replacement virtual service based on user to inventory to here. Okay. And then our catalog here, if I refresh this, now has a status bar here as well. And it's calling every 2 seconds, but each response is okay. If I force the issue with the control refresh. So that's fine. It's working as it should. Now, what happens if we tell Istio, please fail 50%? So here's our destination routes. We have a single route calling inventory at 8080, but we're defining a fault with an abort type of a status return of 500, percentage of time 50%. That's pretty slick. Inventory vs fault. And delete the default route now. That's working too well for our tastes. Oh, I accidentally copied it up out of there. I need to get back in here, make sure that that is what I'm pasting. That's frustrating. I'll do a browser copy. Okay, and now I'll put in the virtual service here with the VS fault, that 50% fault. Okay, and I'm just going to watch. Oh, it's dead. It's alive right here. It's dead. It's alive. Okay, so we're refreshing this page every couple of seconds, and 50% of the time it's coming up dead, 50% okay. So that works just like we'd hope it would. And I'm just going to take a look here. So I can see errors. If I click the link here from the gateway to the inventory application, I get 39% errors. And that's because it's catching up on the last 1 minute. That should come to 50% here eventually. Now, let's try a delay fault instead. So we'll put this in inventory VS delay. And here, there's a single route, but there's a fault defined in the same YAML list element here, the same indent level. And the delay is a fixed delay of 5 seconds, 100% of the time. And now we need to delete the one that works every other time and throw in the virtual service with the procrastination. And now if we look at Cool Store here, it's okay. It's staying okay. Very good. So that new virtual service route worked. And if I look here, I think I'm still looking at the last minute here. Once again, this isn't quite real time. Hey, now our percentage of success is coming up. It's in the yellow. Soon it'll be in the green. The response time on the average, though, has gone clear up to 5,004 milliseconds, which I would call a 5-second delay. Close enough, right? So that is working. So now we can see what would happen with our applications and users if we had a long distance latency or a less responsive application. And yep, there we go. Oh, we can also see this from the application. If we go to the application, don't need to see that. And if I were to take a look at the elements, developer control shift I. Okay. And I'm looking at network here to see the latencies. And I'll start seeing those stack up here as this runs along. Yeah, see, we're going to see increased latencies here. So there you go. Uh, Real cool tool to have built right into OpenShift. You don't have to install it yourself or learn it, the installation. It just plain works. So now we're going to get rid of all this stuff. We're going to delete this user 2 inventory with a delay and go back to default in preparation for the next exercise. And this is circuit breaker, so we're going to see what happens if we do a real flood of calls to this system. I'm going to make sure that my old loop isn't still running. That's the case. Okay, so in here, we're going to tell it we want to do a circuit breaker. So what the circuit breaker does is it's going to take a look and monitor the traffic and say, we're going to allow in this connection pool one max connection simultaneously. On the TCP and the HTTP, one pending request and one request simultaneously per connection. And this is designed to put a little back pressure on the incoming request, fail them quickly rather than have them time out after tens of seconds, and so that you protect the execution of the calls that do come through and the system. Make sure it doesn't crash. So this is an absurdly low number of connection requests, but it's good to illustrate. So we'll put this in the circuit breaker YAML designation file. And run the command to implement that. And it should be working just fine now. Look here. And we're going to implement a siege command to do 10 current connections. So 10 times what we've told it we're going to allow. So we should see some effect. Okay, so we saw SSL errors, but it quickly determined it couldn't make the connection. That's cool. And let's look in the Istio dashboard. Might have that open still. I need to be in the service dashboard under the inventory queries here. So going to that, they go from workload to service. Let me make sure I have that right. Inventory. Quarkus user 1, okay. I'm going to refresh this to reload the list in the dropdown. Okay. And my client request And now you can see that it worked here. We're at 0.53 operations per second, 100% effectiveness. But look at the duration. The duration we started the siege was up around 10 seconds. Once we put the circuit breaker in there, the half a per second, half an operation per second, does come across at full speed. And that siege was very short-lived. Let's do it again. Oops, that's a different project. Okay. Now we should see our operations per second come up. Our success rate will decline temporarily. There we go. Yeah, so that's the effect. We're up to 3.3 operations per second. The success rate's climbing back up. We've gone from the half a per second that our browser supplies in terms of that browser refresh up here. And we're getting 3.3 operations per second from the siege. So that's allowing us a very high success rate, even though we're flooding it with more than it can handle. I can click here and see it too. Yeah, from this vantage point, it's 100%. And the siege is over now. We're at 0 operations per second because I closed the browser. That's how the circuit breaker works. There's this designation in Kiali that this lightning bolt indicates that there's active service breaking going on. It has a service breaker service, and this means it's got a service breaker. Now, as it heals, that'll go away. That lightning bolt. Now we're going to clear do a little cleanup right here. Get things back to normal. Okay, we're going to do a little bit of work now with a single sign-on technique. So this is independent of the monitoring we've been doing, but the single sign-on capability is another tool from Red Hat based on the Keycloak project that can take the authentication responsibilities away from your application and allow you to use JSON Web Token technology that's independently managed across multiple applications with single sign-on. All right, let's do the single sign-on technology, and we're going to create a project that we'll call user2 RHSSO. Very important to have that just right. Okay, I lost track of where my OpenShift cluster is, but if I just take this URL and take it to the apps layer here, if you realize that the console is just another app called console-OpenShift.console, we can get there. And we're still logged in. I'm going to put a create project, paste in that, and there we are. Okay. Next step, we're going to, from the service catalog, we're going to find this application. And here's a note, sometimes you don't see it. If in fact we've got the default designation here of operator backend. Let's see if we run into that. Service catalog. SSO. Yeah, so here it is. We did select this. And I want to see if we need Postgres or ephemeral. Let's check it out. Yep, we want the one with the PostgreSQL. Okay, I can deal with that. And I want to be careful. OpenJDK. To put this information in right. I'm going to move this to the right so I can watch it, my documentation at the same time. No changes are necessary until we get to administrator username. Which is admin. The realm, the password is admin. The realm is Istio. You can tell I've done this exercise before. It's popping up. And we want auth user 2 for me. And the password is the regular Red Hat password. 1G container limit. And I hit create. And there's some annotations to run on this from the code ready terminal. I'm going to wait until the pods come up here. Okay, the database is up. Now the Java application. Java doesn't always start as fast as you might think it would. I know that's going to shock some people. Okay, they're up and going. I think we're done with all these while it's running. And now we've got, we expect to see here. Administration console. Admin will log in. Okay, so now we're going to configure logins for users into applications. So if I go to the login tab, I'm able to tell it I want to log in with email. I do not require SSL, and I can save that. Then I'm going to go to the clients, and here's where I can specify a client application, create one, and I'll put in CCNCLI, the client ID, OpenID Connect is fine, and hit save. And then on the next screen here, we've got the settings tab, and under implicit flow enabled, we want that off, direct grants enabled on. The URL is to the gateway where we hit the application. Actually, that belongs in here. And we click save on this. Then we need to define a role. And the role will be CCN auth. Save that. And now we can go to users. View all users. Brings us our auth user 2 that we defined. And we want to make sure that's enabled. Email verified as off. Impersonate. Okay, that's all fine.